Okay, so now I'm back factoring the same quadratics. So I'm going to go A, B, C. Here's a 1. And so I'm going to multiply 1 times a negative 45 is still negative 45. And then I want two factors to add up to negative 4. So 9 plus a negative 5 or negative 9 plus a positive 5. So I want a negative 4. This gives me a positive 4. This one gives me the negative 4. So I'm going to use these two. But be very careful when you have x to the fourth. So you have to put x squared. Because if you were to multiply them out again, you need x to the fourth. And then you're going to put minus 9 and then plus 5. This is now a difference of squares. You have to be able to recognize that. So now this factors down to x plus 3, x minus 3 times x squared plus 5. And so this would be your final answer. Okay, now let's move on to this one. So this is your A, B, C, and you're going to multiply 3 times 7, A times C, which is 21. And it has to add up to 12. Well, you can only multiply 3 and 7 to get 21, but 3 plus 7 gives you 10, or negative 3 and a negative 7. If I multiply two negatives, I get a positive 21, but then that would give me a negative 10. Does not give me 12, so this is a prime. You cannot factor. It cannot be factored. Sometimes that can happen. Okay, now this one, we're going to have A, B, C. So 2 times negative 15 is negative 30. And you want the factors to add up to B, which is 7 in this case. So we're going to have negative 10 plus 3. That gives me negative 7. Or 10 plus a negative 3. Oh, here it is. That gives me positive 7. So I'm going to use those two factors. But remember, A is bigger than 1. So you have to put it twice. So you have to put it twice. And then you're going to do plus 10 and negative 3. And so now you have to reduce. So you're going to divide this by 2. And you're going to get n plus 5 and 2n minus 3. So that's your final answer. The other way you could write it is as 2n minus 3 times n plus 5. So these two could be your answer. Okay, good luck with the factoring.